Today we're going to talk about multiplication by hand. Now, what does that mean, you ask? And you might wonder, well, does multiplication by hand mean what is 9 times 7? And the answer is sure, if you wanted to, except that single digit multiplication, 9 times 7, 4 times 8, 6 times 5, all of those are memorized. Or if they're not memorized, you need to get to memorizing them. So when I talk about multiplication by hand, I'm talking about pencil and paper and multiplying numbers when at least one of them has more than one digit. So we might talk about something like 487 times 79. There's an example of something we would need to learn to multiply by hand. Or even 487 times 9. So I want to remind you, because you know this is a leftover from probably 4th grade, but I want to remind you of the method, and the mathematical term for method is algorithm, the algorithm we would use to solve a problem like this. So we simply multiply one number at a time. What is 9 times 7? And the answer is 63, but we've got to carry the 6 up here. 9 times 8, which is 72, but we've got to add in the 6, so we get 78, and we carry the 7. 9 times 4, which is 36, but we have to add in the 7, so 43. So that's the trick to it. One number at a time and carrying any number beyond a single digit. Let me show you another one. Let's do 273 times 4. So 4 times 3 is 12. And you can see how that and that create our 12. 4 times 7 is 28, plus 1 is 29. So there's the 29. 4 times 2 is 8, plus 2 is 10. And then on that last one, we put the whole thing in. So here's what I want you to do. I'm going to put one up on the board, and I want you to pause the video, solve it yourself, and restart the video and see how you did. Okay? Go ahead and pause, and I'll wait. All right, now we're back. So hopefully what you did is 7 times 6, you got 42. 7 times 7 is 49, plus 4, 53. 7 times 1 is 7, plus 5 is 12. 1,232. Okay? If at this point you are feeling lost, then you should definitely decide to, sometime over the next few days, join me on Zoom and we can talk our way through this. Let me give you a couple of other strange examples. So let's say we want to do 187 times 17. Okay, so now we've got a 2-digit number here instead of a 1-digit number. So let's see how we do that. 187 times 17, and we're going to use the same method. 7 times 7 is 49. 7 times 8 is 56, plus 4 is 60. 7 times 1 is 7, plus 6 is 13. I hope you're starting to realize how crucial it is that you've got your multiplication tables memorized and how practiced you are at adding numbers, because you don't want to spend time in the middle of this trying to remember what 7 times 8 is. Now, here's the tricky part. This is the only tricky part to the whole thing. When I go to multiply the second number, I've got to acknowledge this space with a 0. So when I come down to the second row, I first drop in a 0 to fill the ones place. Now I can do the same thing. 1 times 7 is 7. 1 times 8 is 8. 1 times 1 is 1. And you can see now, when we're doing this the second time, these go away, right? And now we just add it up. 9, 7, 11, 3,179. Now here's something I wondered. I always put the bigger number on top and the smaller number on the bottom. But I asked myself, do you have to do that? Could I do it this way? Could I say 17 times 187? Now you have to admit, that just looks weird, right? But let's see if the algorithm still works. 7 times 7, 49. 7 times 1 plus 4 is 11. Put in our 0. 8 times 7 is 56. 8 times 1 is 8, plus 5 is 13. Now, since it's our third row, we put in 2 zeros. 1 times 7 is 7. 1 times 1 is 1. 9, 7, 11, 3. Same number. So it doesn't matter whether you do it this way or this way, but you can see one thing that does matter. Here, it took us 2 steps. Here, it took us 3 steps. The number of steps is always going to be equal to the number of digits here. So that's why we put the smaller number on the bottom. Not because we get a more correct answer, but because we get fewer steps to get to our answer. All right? So again, if this is easy, yay. If this is really difficult for you, find some time to join with me on Zoom and we can practice this.